Hi, so this is a third video for PFD and BFD. Okay, so yeah, okay. We are, let's say, in final exam or in the test, you are given this kind of chemical processes that you have to convert to a block diagram. So first you have to read the question or chemical process description here carefully. Okay, hydrogen gas is a valuable product as it's used as feedstock for many chemical processes. A common way to produce high purity hydrogen gas is by a reaction of propane gas with steam using the following scheme. So from the question, we can say this is our product hydrogen, and then it's used as feedstock for tak adalah, ini just apa orang kata introduction. A common way to produce high purity hydrogen gas is by reaction of propane gas dengan steam using the following scheme. First, the propane gas is first sent to a desulfurizer. Okay, so this is our first block. To remove any sulfur present in the propane gas because the sulfur would poison the catalyst in the latter process. Number 2, steam is added to this desulfurized propane and the combined gas is sent to reforming furnace. So furnace here is our second block. Betul tak? Okay, second. A fire heater at ni dia punya temperature setting to produce reforming reaction. So the reaction, chemical reaction is given propane plus steam, H2O lah kan, steam, produce CO2 and H2. So CO2, you know that this is a byproduct ataupun kita panggil unwanted product. What we want is this one. Nampak tak? Boleh bayang tak? So basically there are two stream from one device ataupun one block. Okay. The number 3, the gas mixture from CO2 converter. Kan? So this is a third block. Okay. Enters masuk ke dalam absorber, CO2 absorber. Okay. So this is our fourth block, where most of the CO2 in the mixture is absorbed into an amine solution liquid lah. The gas mixture from CO2 absorber now contain H2 with traces of CO2 and CO. So there are two unwanted ataupun byproduct. The last trace of CO are converted to methane in methanato. Dalam methanato ni adalah our fifth fifth block. Okay. So kalau lah saya bagi soalan ni, boleh buat tak agak-agak? Boleh nampak tak? Yang mana? First block, enter first block, and then how many block should we have at the end of this orang kata problem? Okay. And what is the reaction in between, and then stream flow from left to right or right to left, macam mana semua. So you have to identify. Okay, so you dah nampak kan? So but please keep in mind that some of this block may represent more than one piece of equipment in the actual process. Okay. Try dulu, saya bagi 2-3 minit untuk awak fahamkan betul-betul soalan tu. Betul ke saya dapat 5 vektor? Macam mana awak? Awak dapat 5 ke? Ke 6 or less than that? What do you think? So, tengok next apa? So, kalau okay, dapat juga 5 blok, faham kan? Kita dapat 5 blok je. So, this is simple straightforward question actually. So, first block saya tulis kat sini kita ada propane gas, propane in enter, first block apa dia? Desulfurizer, betul? And then kita diguna steam kan? So you can put here steam. Then next dia kata apa? Steam is added to desulfurize propane. Maksudnya dekat dalam kan, ni kita letakkan steam, and then dia kata lagi reforming furnace, dalam reforming furnace. Okay, and then kat sini dia bagi reaction lagi, dia guna H2O, maksudnya dia masih guna steam. You can put steam here, or you can put steam here lah, mana-mana steam. Okay, and then apalah, dalam final exam sama ada you nak buat macam ni ke, you nak buat apa, colorkan pun tak apa, mana-mana je. Okay, you can put T, temperature equals 1500 Fahrenheit. Okay, the gas mixture from CO converter enter to, okay, maksudnya CO2 from reforming reactor or reforming furnace will undergo CO converter. Ini CO converter. And then CO converter enter the CO2 absorber. Masuk lagi satu kolom. Satu blok. CO2 absorber. Okay. Where most of the CO2 in the mixture is absorbed into an amine solution. And then the gas mixture from the CO2 absorber now contain H2. With ni, the last vessel converted into methanato. CO2 ni masuk ke dalam blok methanato. Okay. So the end product is, dah cukup lah, hydrogen gas ataupun hydrogen in bracket gas. Okay, inilah jawapan dia. Can you translate this BFD into this chemical process description? Let's say kalau saya bagi chemical block flow diagram, can you convert it into this description or not? Maksudnya you should be able to read BFD block ni dalam bentuk sentence or statement. Okay, clear So next, okay, note on notation. Actually I just introduce here the notation because you have to get familiar with this notation, because this is a very fundamental or basic in mass balance, energy balance. Okay, maybe not next week, the following week we will have a lecture on the mass balance ataupun mass and energy balance. Okay, in BFD ataupun dalam BFD, actually you have to put this notation instead of let's say mass is given 200 gram per 200 gram, so you put like this, M equals apa, put the unit, gram ke, kg ke, volume apa. Okay, so you have to put the unit notation. Okay, V dot. So you have to understand lah what is V dot, what is V, what is M dot. Okay, that's it for today. But here I would like to give you 2 questions. Check your understanding or to construct BFD. First, I think you just do it, and then maybe next week we will discuss this during online class. Okay, next week, yeah. And then before I end the class today, I would like to recap how to construct BFD. I think PFD, process flow diagram tu tak ada apa-apa sebab it's just for your knowledge, because you will use that for your unit ops, dan satu lagi tu chemical plant design ataupun CPD ataupun integrated design project IDP. Okay, basically in BFD is a simple, you should have a simple block. Okay, first it can be square or rectangle, and then let's say this is stream in, stream out, and then maybe you can put here something below. So you can put A, B, and C. This is the simplest way to represent instrumentation, material, reaction, energy balance for calculation. Okay. Basically, the BFD is the beauty of BFD is that it's designed to be simple and only show main process. Okay, happen for that particular chemical processes ataupun in apa orang kata dalam satu product to produce something lah. Okay, and then first, flow is from left to right. Okay. Okay, flow dia adalah left to right. Don't forget the arrow. Nombor 2, kenapa apa yang perlu ada dalam BFD adalah equipment represented by block, square or rectangular, sama ada square ataupun ini je. Jangan yang lainnya. Tak boleh bulat ke triangle macam saya cakap tadi. Only critical pieces of equipment are shown. Critical equipment only. Okay, and then flow shown with arrows. Macam ni lah, kena ada arrows. And not all stream are shown in the dalam BFD. Nombor 4, kalau ada flow rate, concentration, kalau in your question is given the flow rate, concentration are given, then you should put the value and unit. Jangan lupa. Nombor 5 adalah okay, ingat ni, lighter material density ataupun lighter. Satu lagi dalam more dense lah, kita kata yang lebih berat. The lighter component or more volatile lah, ataupun gases, volatile components are shown, kata kita ada plot kat sini, are shown higher up on the diagram, and then the more dense material is at the bottom. Okay, lighter bottom, dense material. Okay, and then number 6, please remember that if there is a crossing line, okay, crossing line, kata you nak daripada block 1 to block 3, okay, you want to this one going up, contoh, please don't do like this. Okay, vertical line, not the horizontal, vertical ya. The vertical line must be broken. Maksudnya macam ni kan, vertical line must be broken ataupun okey,